All right, good morning, guys. This is actually going to be a presentation on 1.04 and 1.05. So let's get started. So first off, we want to measure lengths, and we usually measure that on a ruler. So a ruler can be used to measure the distance between 2 points. 1 point can correspond to one and only one number, okay? And that number is called a coordinate. So we're going to take a look at being on a number line in a second. We can find the distance between 2 points by either just counting the units between them or actually subtracting, or subtracting the coordinates of the points. For example, I can subtract a minus b, or I can subtract b minus a, whatever those coordinates are. Just know that it has to be an absolute value. The reason why is because doing it one of those ways will always result in a negative number. And we know that there is no such thing as a negative distance. For example, you cannot walk backwards and say that you walked negative 5 feet. No, it doesn't work like that. You walked 5 feet, you just happened to walk backwards. So that's how that works. Absolute value will always give you a positive number. So if you ever get a negative number, know that you're doing something wrong when it pertains to distance. So let's take a look at the things I just talked about with this example. So the coordinate for point A is -2, the coordinate for point B is 1, and the coordinate for point C is 3. So if I wanted to find BC, okay, notice BC is this line segment right here. Well, that's not hard because I can just count 1, 2. So the length of BC is 2. Now I'm going to show you how using the formula works, because guys, if your points are like really far apart, maybe in the thousands, you don't want to have to count all those little tick marks. So I can either do 1 minus 3, or I can do 3 minus 1. Notice I'm putting in an absolute value. Only one of these ways is going to give me a negative number, but I'm going to put in an absolute value either way. 1 minus 3 is a -2, and the absolute value of -2 is 2. Or 3 minus 1 is 2, and the absolute value of 2 is still 2. Absolute value does not change the sign of the number. Too many times I get kids say that absolute value of 2 is -2. No, no, no. The absolute value is always going to end up positive when you're taking a number that's negative or positive from the inside. All right, let's take a look at AC. Now we can easily count AC to be 1, 2, 3, 4, 5 units. So I know I should get 5 when I do my little formula. So I'm going to do my little formula. -2 minus 3, those are the coordinates for A and C. Or you could easily do 3 minus -2. Now I know this is going to scare some of y'all because there's negatives involved because of that point A. But have no fear. Use your calculator if you're not 100% sure. Same signs I add and keep. So add 2 plus 3 is 5, and I keep the sign. The absolute value of -5 is 5. Now, in this scenario, two negatives back to back like that, they have a magical power and they turn positive. So 3 plus 2 is 5, and the absolute value of 5 is 5, which is exactly what we counted. Yes, you can always count, but counting's not always going to be the easiest method for you, especially when we have variables, which you will see when we do the problems at the live session, which hopefully you will attend. All right, this starts section 105. And it says congruent segments are segments that have the same length. In the diagram, PQ is equal to RS. So we can say that PQ is congruent to RS. We show that by using the tick marks. And the tick marks are in red. You can see them right here. So the same number of tick marks found on each segment mean that they are congruent. So PQ is congruent to RS. Now, which means they also have the same length. So if I said PQ is 5, guess what, guys? RS is also 5 because those two are congruent, and congruent segments have equal length. Not all the time will it just have one tick mark. There's some scenarios where I might have 2 tick marks. For example, if I have these 2 triangles, this one might be congruent to this one. This one might be congruent to this one, and then this one might be congruent to this one. That's how I would show more than one segment congruent. I would just keep adding tick marks. And the number has to match up though. So 3 matches up with 3, so those two segments are congruent. They would have the same length. All right? Let's take a look at this. It says, in order for you to say that point B is between 2 points, okay, visualize that, points A and C, and point B is somewhere in between those two. All 3 points must lie on the same line. So what that means is AB plus BC has to equal AC. Now I'm a very visual person, so I have to draw this. So looking at my first statement, it says, in order for you to say that point B is between A and C. So that means my endpoints are A and C. B has to be somewhere in between it. A lot of kids think that it has to be in the middle. It doesn't. It's just going to be maybe right here. It could be at this point. It could be in the middle. It could be right next to A. We have no idea. We just know that it's in between. All right, so what this is saying that if it is on the same line, then if I add this segment with this segment, then that should mean that it should total that segment. Think about frogs. If you had 2 frogs, one frog jumped the first route that I took, okay? One frog was lazy and said, I'm just going to jump from A to B, and then I'm going to jump from B to C. And then the second frog came around. He's a big macho man, been working out, and he just takes one big leap and makes it to C. Essentially, those 2 frogs went the same distance if those two actually sum up. So for example, let's say AB was 2 and BC was 6. Then I would need AC to be 8 in order for all 3 points to be on the same line, because AB plus BC is AC. So 2 plus 6 needs to be 8. This is actually a fancy term called the segment addition postulate, which says if you have 2 small pieces that has to sum to a bigger piece if they are on the same line. All right, so think about your frogs. If I jump 2 jumps and somebody comes behind me and jumps 1 big jump, that should be equal if I sum up the 2 smaller ones. Segment addition postulate. Now here's how we're going to do this example. First off, I just see words, so I know I'm going to be drawing me a picture. It says G is between F and H, so my endpoints are F and H. And it says FG, it says G is between. So if you want to put it right in the middle, you can. I don't like putting it right in the middle because I don't want kids to think that it has to be right in the middle. So it says FG is 6 and FH is 11. So FG is 6. And the whole thing, FH, is 11. So they want us to find what is GH. So by the segment addition postulate, the 2 small pieces have to add up to the big piece. So hopefully you can just see this and know that that GH has to be 5 units, whatever the units are. Okay, because I need 6 plus what to give me an 11. Okay, by the segment addition postulate, 6 plus what gives me 11. And so then I subtract 6 from both sides, and I get that X has to be 5, and I should have labeled GH as X. And so now GH is 5. So that's how you would do that. We're going to be doing more of these problems in the lesson, so please make sure you attend. Right now, I'm going to show you how to create, there we go, how to create a line segment. Okay, so in order to create a line segment that has the correct markings, the spacings correct and everything, I'm going to you would use a ruler. Okay, I am going to use my shape tools. And so you would just draw a horizontal line and put 0, maybe in the middle, wherever you really want. Okay. Then everybody should have received a compass. So then you would take your compass and you would set it to whatever desired length you want. Okay. And I'm going to put my point at 0. I am going to arc a spot on the number line. So that would be at the coordinate 1. I move my point and I arc again. Now that would be at the coordinate 2. Move my compass and arc, that would be at 3. I can do the same thing with the left side of 0 to get my negative numbers. So arc here, move over my compass. Arc here, move over my compass. And arc here, move over my compass. When I am finished, I have created a number line with correct spacing. So this would be 1, 2, 3. This would be -1, -2, and -3. All right, that's just if I had a straight edge and a compass. All right, hopefully I see you at 10 to 10:30 today. We'll be working problems. Have a great and glorious day.